Hello, my name is Robert Hunter. I am your teacher, Chrissy's Hunter's husband. She has strep throat again, so she's talking about like this. And she doesn't want y'all to get too far behind, so she asked me to go ahead and make a video for you for your section. So this is section 3.6, 3-6, whatever, solving system using matrices. So, I'm not positive how deeply y'all have gone into matrices before, so I'm going to kind of act like y'all really don't know much at all, and that's okay. You may know more than I let on, but I'm just going to assume and move from there. Okay, so a matrix looks like this. All right, a matrix is essentially a collection of numbers. All right, you can have a 2 by 2 matrix, like 2, 3, 9, negative, 3/8. Whatever, they can be fractions, they can be decimals, anything. They can be a 2 by 2. They can be a 2 by 5. So like 1, 2, 3, 4, 5, 6, 3, 9, 8, 7, whatever. But it's just essentially a collection of numbers. Let me erase all that we deal with. Now, in a matrix, you have rows and columns. So let's say this is 1, 2, 3. This is 2, 1, 2, 2, 23. This is 31, 32, 33. Okay? So these are your rows. This will be row 1, row 2, row 3. Let me do those right. This is row 1. This will be row 2. This is row 3. And then you have columns. This is column 1, column 2, column 3. Okay? And basically, this would be a 3 by 3 matrix. That's what we would call it. We would call it a 3 by 3 matrix because it is 3 rows by 3 columns. All right. Later on, we'll be dealing with a lot of 2 by 3 and a lot of 3 by 4 matrices. We'll get into that a little bit in a minute. But first things first. So a few things about these. There's a level of which that the order can be messed with a little bit. So if I decide, let's stick with the same color. If I decide to switch any 2 rows, all right, if I wanted to, I could switch row 1 or stop it, row 1 and row 2. All right, all I would have to do is go like this. I would have 2. Stick with your colors. We would do 2, 22, and 32, and then we would do 1, 21, and 31, and then we would have 3, 23, and 33. All right, and this technically is the same matrix. All right, it is exactly the same matrix. Now we have switched 2 of the rows, but these represent the same formulas. They represent the same set of data. They're just in a different order. Okay? They represent the exact same data. They're in just a different order. Now, I can't just mix anything anywhere. I can switch any rows that I want, but I have to switch the entire row. So if I want to, I can go from here and switch rows 1 and 3. So again, I'll stick row 3 up top. 3, 23, 33. My row 1, I'm leaving it alone, 21, 31. And my row 1, which was 2, 22, 32, I stuck it on bottom. Cool? I can multiply a row by a constant. So let's take my original again. Let's say I took this original and I took 1, 21, 31, 2, 22, 32, and 3, 23, 33, and I decided to multiply one of the rows by a constant. So I can multiply row 1 by 2. So we're going to multiply the entire row by 2. I'm going to multiply the next one by 3. Okay? But I have to be consistent all the way across. So what I've got is now row 1 will be 2 times 1 is 2. 2 times 21 is 42. 2 times 31 is 62. Okay? Then I'm going to multiply the second row by 3. 3 times 2 is 6. 3 times 22 is 66. 3 times 32 is 96. Had to think about that one for a second. And then row 3, I didn't multiply by anything. All right, this is considered acceptable. Now, these aren't perfectly the same anymore because they have been scaled, but depending on how you're using these data, that is a perfectly legitimate thing to do. All right. Another thing you can do is you can add one row to another. So I'm going to pause the video and I'm going to change. So if you're still copying, pause it, but here we go. The last thing we're going to deal with is we can add one row to another. So let's do 1, 2, 3, 5, 7, 9, 12, 13, 14. Okay? And let's say I want to add row 1 to row 2. I wanted to combine those two together. Right? I could do that and create a new equation. Basically what would happen is I would do 5 plus 1 is 6, 7 plus 2 is 8, 9 plus 3 is 12, and then 12, 13, 14. I've actually essentially condensed my matrix. Right. I've gone from, these actually represent 3 separate equations, and since I've combined 2 of them, just like you would in elimination, all right, you remember with elimination you'd have 2 equations and you'd subtract them or add them in order to eliminate an x or eliminate a y. Same idea here. This represents an equation and another equation. Essentially what we have done is added the 2 together. And now instead of having something like 1x plus 2y equals your constant, and 5x plus 7y equals another constant, I added those 2 together, and I'm left with 6x plus 8y equals 12. All right, now that's not always what's going on here, but that is one way of looking at this, is these all represent equations. All right, and then last but not least, you can combine any of these steps. Like I can multiply by a row and then switch it with another, or I can multiply something by a row and then add it to this one. So if I wanted to, I could multiply this one all by 2 and then add it to row 2. All right, just like you would with elimination. Remember when you would multiply one of these by something so that it would cancel out with the next row? All possible. All right, let's get to the nitty-gritty. How do we get our way around these things? So I'm going to pause again. Pause. Problem 1, all right? What is element A23 in matrix A? Okay, what this is this represents a specific cell in this matrix A. All right, specific data point. And it literally is A gives you the row, gives you the column. Okay? So A, the row is 2, so we'll go to row 2. The column is 3. Go to column 3. That would be 8. Okay. So A, 2, 3 equals 8, because that is the second row of the third column. Now, to kind of show you one other thing real quick, this is actually a 3 by 4 matrix. That is its size, because it is 3 rows high and 4 rows across. Okay, it's always going to be rows by the columns. That's how we're going to identify these things. All right, and it always comes first, even when we talk about identifying a specific cell, like this A23. It's row first, column second. All right, letter B, same idea. What is element A32 in the matrix A? We'll go to row 3, column 2. What did I just do? Mr. Lexdexic. A3. Column 2, that would be the negative 2 right there. So A32 equals negative 2. Cool. Pause the video real quick, try letter C and D, and then I'll come back and do them. All right? Pause. All right, hopefully you paused it. If you didn't, go back and pause it now, please. All right, here we go. Element 1A13, well, row 1, column 3, that would be the 1. So A13 equals 1. Okay. Element A24. All right. Row 2. What did I just do? Ha! Hopefully you caught it. Mr. Hunter, what are you doing? We want our old teacher back. No, you don't. A13. 1. Mr. Hunter can't count. 1, 2, 3. It's actually the 17. A13 equals 17. Okay. A to 4. All right, that's row 2. This is row 4, so that's the 6. So A to 4 equals 6. Cool? And that's how we identify these. All right, we're going to pause and turn the page. Okay, hopefully you've turned your page by now. Problem 2, A, B, C, and D. Represent the system of equations as a matrix. Okay, remember what I said earlier where it looks, a lot of these times are like x plus y equals a constant? All right, so what we're going to do is we're going to make sure we put all of our x's in the first column, all of our y's in the second column, and then all of our constants in the third column. All right. If we have a third variable, we do x, y, z, then our constants. All right. But we always kind of have to have it in this format before we do anything. So I have my x, my y equals the number. X, my y equals the constant. So here we go. Let's build it. Put your big bracket and just grab the coefficients. The coefficient of x is 2. The coefficient of y is 1. The constant is 9. The coefficient of x is 1. The coefficient of y is -6. The coefficient of the constant, not the coefficient of the constant is -1. Now this is called an augmented matrix. I don't know if your book uses that term, but if it does, my book does, so if it does, it calls it an augmented matrix. And oftentimes, you'll see this with a bar right here. All right, that does not have to be there, but oftentimes it's got a bar there. Or I've seen some books actually used a dash line right there to indicate that this is a system of equations, that this is some value, this is another value, and that this is the constant that they equal. Okay? You are not. I am not requiring that you put those there. Miss Hunter might, but as of right now, I'm your teacher, so who cares what she says? Okay? She can fix it when she comes back. All right? She can't say anything right now, anyways. Cause she sounds like this. Okay. Just in case you'd forgotten. All right, but that's your augmented matrix. All right. Letter B. Represent the system of equations as a matrix. Okay, so here we go. First things first, you may notice that these aren't all in the same order. Like, this has got a y over here and x over there, all sorts of weird stuff like that. So the first thing we have to do is get everything in order. Put your variables in order and put your constants on the right. So that's what I'm going to do first. I'm going to do, the first one is already set up and ready to go. X minus 3y plus z equals 6. The second one is kind of in order, but it's x 3z equals 12. All right, you do not have to leave the space right there, but I left the space there, and I'll tell you why in a minute. Okay? Last but not least, my y is already on the left-hand side, but I need to move this x to the other side. So you add 5 to both sides, and you get positive 5x plus y. There are no z's in this one, equals 1. Now, here is why I put those there. All right? If it is lacking the variable, the coefficient is 0. There is 0 y's right there. The coefficient here is 0 z's right there. You have to put that in your augmented matrix. If you do not put that in your augmented matrix, it is wrong. It is actually completely wrong. There's really no salvaging it. Okay, and this is one of the most common mistakes because you're like, oh, you just start putting coefficient, 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 and you just keep doing them real quick, and you forget that, oh yeah, I got to put in my zeros. So now that I got everything lined up, I can go, well, 1, -3, 1, 6. Those are my coefficients for my first equation. And the next equation is 1, 0, 3, 12. That's my second equation. Then 5, 1, 0, 1. Cool? And let's think back to one thing real quick. Remember when I told you I could switch 2 rows and it doesn't matter? Okay, switching 2 rows is tantamount to, hey, what if I wrote this equation up here and then wrote this equation second? Would it matter which equation I wrote first? That is why I can switch the rows. It's because it doesn't matter which equation I write first. It really doesn't. That's why we can switch the rows. All right. The reason I can multiply an entire row by a constant is, remember when we solved by elimination, I can multiply the entire row by some constant. In this case, I can multiply this one by a -5 to get that x to cancel out with that y. All right. Same idea. That would be tantamount to multiplying that row by a constant. That's why those rules work. So let me clear all this out so we can get back to where we were. All right. But anyways, didn't care about that. That's fine. That's your augmented matrix. Pause the video. We're using the honor system. Pause the video and see if you can try C and D real quick. Okay? Did you pause the video? If you didn't, shame on you. If you did, great. This is what you should have gotten. -4, -2, 7, 3, 1, -5. That would be your augmented matrix for this system of equations. It's already built. You've got your x's, you've got your y's, you've got your constants, all on either side of the equation. All right, the next one. Is it in order? No. So let's put it in order. We got 4x minus y plus 2z equals 1. We've got y plus, oh, not y, Mr. Hunter did it, 0x plus y plus 5z equals 20. And I know writing 0x is semi-improper because you never write 0 plus anything. But that's okay. Mr. Hunter, you remember Miss Hunter? She can't complain about anything right now anyways. This is how she sounds. So, she complained about the way I teach you later. Plus 0z. She's right behind me laughing. Equals 7. Cool? So that's everything in order. You wrote your augmented matrix. 4, 0, 2, -1, 1, 1, 2, 5, 0, 1, 20, 7. And there you go. Cool? Oh, she erased it! That's as loud as she can speak right now, everybody. Alright? That's about as loud as she can get. Alright. Let's keep going. I'm going to pause the video. Turn the page. Problem 3. What linear system of equations does this matrix represent? So this is another augmented matrix. It's what size is it? Yes, it is a 2 by 3. Oh, my markers went away. My markers. There we go. It is a 2 by 3 matrix because it is 2 rows high and 3 rows wide. All right. So the linear systems, and remember I told you that bar right there. All right. Some books do it, some books don't. You don't have to do it as far as I'm concerned, but Miss Hunter may say otherwise, and that's fine. So what linear system of equations does this matrix represent? Well, 5x plus 2y equals 7. And, 0 x's, so I don't have to write that one at all, plus y equals 9, which I really don't have to write plus at all. This is simply y, because there's only one of them, equals 9. There are no x's, 1 y, and a constant of 9. This one says there are 5 x's, there are 2 y's, and when you add them together, you get a total of 7. Cool? Pause the video, try letter B. Alright, again, if you didn't pause the video, shame on you. So this one says, if I have 2 x's, 0 y's, it equals 6. So 2x equals 6. Alright, this one says, if I have 5 y's, if I have 5 x's, I've got negative 2 y's, it equals 1. So 5x minus 2 y's equals 1. That is your system of equations. Cool. And I guess I'll box this one in purple too. That way we're nice and even. Pause. All right, here we go. Find the solution to the system of matrices. Here is what we're getting at. Okay, we are going to give you a system of equations. We want you to use it to build a matrix, and then once you get that matrix, we will use our calculators to get the answers, get what x, y, and z equals, the solution to the system. Okay, so first things first, you'll know how to build it, blah, 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 blah. So we're going to go, here's our matrix. Let's try that again. Here's our matrix. 2, 2, 3. Why is there a 2 up there? It's 1, 2, 3, -2, -3, 4, -2, -5, 1, 6, 7, 2. Everything is already in order for us. Okay? Okay, Miss Hunter is screaming at me as loud as she can. She's going, bar, bar. Okay, she wants me to put this bar in there. So there you have it. We are to put the bar in there from now on. Okay? Whatever. Have at it. It's her class. So we're going to put this into the equation, into our calculator. And what we're going to get, she is a mathematician. I am not. So that's fine. We are going to put this in our calculator. We are going to run a specific function called an ref. That stands for reduced row echelon format, I think? Form. Okay. And it's going to look like this in your calculator. It's going to have that parentheses right there. Now the fun part about this is in your calculator, you're going to have you're going to have a ref, and then you're going to have an ref. It's going to be very tempting to pick this one. Pick the pirate one. The ref. Okay? Pick the pirate function. Not the ref. The ref. We want a pirate referee. Zebra stripes and all. Okay? So, once we run an ref on this, we are going to get a matrix that looks like this. 1, 0, 0, 0, 1, 0, 0, 0, 1. And then we're going to get some numbers over here. Okay? She's yelling bar again. Okay? We're going to get some numbers over here. These numbers are going to represent your x, your y, and the z coordinates of your solution. All right? And really the way this reads, if I have one x but no y's and no z's, this is what it equals. That's literally what this means. The next row, if I have no x's, one y, and no z's, this is what it equals. So 1y equals whatever gets put right there. Same idea on the bottom row. If I have no x's, no y's, if all I have is one z, it equals this. So therefore z equals whatever is in that spot. Cool? That is how this reduced row echelon form works. All right? So, how do we get there? I thought you'd never ask. We are going to go into matrix 3 times. So, we're going to hit second matrix. It is right above the x to the -1 button. All right, I'll show you where this is in the calculator in a moment. So, second matrix. And we're going to go in there 3 times. All right, the first time, we are going to edit. Then you quit. You have to exit all the way out of it. All right, the second time, we're going to choose our function. Go to calculate. Or is it math? I don't know. It's the second row. I think it's math. If it's not, I'll go edit that in a second. And it's ref. All right, and it kicks us out. And then we have to go a third time, and we have to choose our function. We have to choose, it's in the first row. Like if we edited matrix A, we have to choose matrix A. If we edited matrix F, you choose matrix F. So your calculator will now read R, E, F, parentheses, bracket, A, bracket. And you hit enter, and you will get something that looks like that. Okay? So here we go. Let's put this in our calculator together. Okay, hopefully you got all that stuff written down because I had to erase it in order to do this. If you lost it, just back up a little bit, go get it all copied down, and come back, okay? But here we go. This is how we're going to enter it in, okay? We're going to go to second matrix, which if you'll notice, the matrix is in yellow right below. So if you hit the alpha key and go down to, that's the matrix button, M-A-T-R-X. That's what this one says. Yours should say I-X, but whatever. So hit second matrix, and you get something that looks like this. Ooh, I knew it said math. I was right. So then we're going to go 2 to the right into edit. Under A, like you can use any one of these you want, but I always use A just because it's force of habit. So hit enter. Now we're in the editor. The size of this thing, remember, it's row by column, so it's 3 rows by 4 columns. And it builds a 4x4 matrix, 3x4 matrix. And I can scroll around and look at this. See, it scoots left and right for me. That's item 1, 1. That's item 1, 2. That's item 1, 3. That's item 2, 3. So on and so forth. And so what we'll do is we'll put all these in there. Now, it's easiest to start with the first one because when you hit enter, it moves one to the right. You hit enter, it moves to the right. Hit enter, it moves to the right. And then it goes over. So it's easiest to go start at the top and scoot over. And then it'll automatically go to the next row, scoot over. So we're going to hit 1, enter, -2, enter, -2, enter, 6, enter, 2, enter, -3, enter, -5, enter, 7, enter, 3, enter, come on, 4, enter, 1, enter, 2. And we'll get them all in there. All right? And if you want to double check your work, make sure you got 6, 7, 2, -2, -5, 1, -2, -3, 4. All right, 1, 2, 3, because it only takes one of this to be wrong and go squirrely. All right, so that's step 1. Get them all in, and then quit. Quit is the button right above mode. So if you hit second mode, it'll quit you at anything. Then we're going to go back in again, second matrix. Scroll over to math and go down to the pirate function, the R ref. All right, not the ref. Told you that was there. Don't get pulled up by it. We want the pirate referee, the R ref. Click that. And then, so many of my students like to hit enter and go, but Mr. Hunter, it didn't work. You're right, because you weren't done. All right? So go to R, hit RF, and then go back in one more time. Matrix. There are many matrices here. Matrices. Pick the one and whatever when you edit it. I edited A, so I'm going to choose A. And I hit enter. And that is what I get. So your function is x equals 4, y equals -3, z equals 2. All right, and let's start writing. Now I can write, because I can't write and change the screen at the same time like that. So, so in this case, x is your first one, 4. Y is your second one, -3, and z is your third one, 2. Again, that's because if I have one x, no y's, no z's, it is 4. That literally is x equals 4. The second row is y equals -3. The third row is z equals 2. That is what those mean. All right? And finally, I believe this is how Mrs. Hunter wants you to write your answer, as an ordered triple. 4, -3, 2. And just like a single point is an XY, an ordered triple is an XYZ. Alright? This is your final solution. Now I'll let her correct me on that if she wants it otherwise. But for the time being, get used to writing as an ordered triple. Remember, they're in order. X, Y, Z. Alright? That's how you do this. Let's find the next few. Okay? Pause. Alright, letter B tells you to do it. Make you do it. Alright? But if you didn't, that's fine. I understand. Doesn't mean I'm happy about it. So if you wrote your matrix, no, not put a box. If you wrote your matrix, you put 1, 3, -2, you put -3, -7, 3, you put -1, 1, 0, because there's no z's in that one, and -9, -9, 7. That's your original matrix. Okay? Then you stuck it in your calculator. Okay? Remember, second matrix, all that good stuff? So let's do that real quick. Exit annotation mode 2. Here, discard. And I'm going to go back to second matrix. No, not add 1. Second matrix. To edit. And it's already the right size. So I'm going to go 1, -3, -1, -9, 3, -7, 1, -9, -2, 3, 0, 7. Let's make sure I put these in because I'm trying to move it with a mouse and look at the screen at the same time. It's kind of messing with my eyes a little bit. 1, 3, -2. Good. So then we go second. Actually, I can quit. Got to get out of here. Second matrix RF, second A. Or if you've already got it like this, just hit enter and it does it again. All right. But again, in case you didn't know that, go second matrix. Scroll down from math down to RF. Hit enter. Then go one more time, the third time in, choose your matrix, matrix A, hit enter, and you get, voila! X is -2, Y is 1, Z is 4. Drawing mode. So your answer is -2, 1, 4. That's your solution set. Cool. Try the next problem. Alright, problem C you can do on your own. Problem 5. Use a calculator to find the solutions. Problem 5, A and B. You can do both of these. The only difference is A, B, and C have been replaced. Have replaced X, Y, and Z. But the deal is, whatever letter you put in first, that's the first. Oh, come on, come in. Whatever letter you put in first. What happened there? Pause. All right, all better. Whatever letter you put in first, that is what's going to come out when you get your 1, 1, 1, 0, 0, 0, 0, 0, 0. Whatever letter you put in first, that's what's going to come out first. Whatever letter you put in second, that's what's coming out second. Whatever letter you put in third, that's what's coming out third. Okay? So you could put B, A, C. That's fine. Just remember, your answers are going to come out B, A, C. Okay? It's doable. Just it's easy to make a dumb mistake that way. And Mr. Hunter is full of dumb mistakes. Just ask Mrs. Hunter. She'll let you know. But she'll let you know like this. Okay, so here we go. We stick this in our equation, and you get the answers 0.5, which is 1/2. 0.6666666 is the sign of the Uber Devil, which is 2/3, and then 2. Okay? This one, you stick that in your equation. Don't forget, 0 is an A value right there. Just like over here, 0 was a B value. Okay? It's 0 B's. Alright, and you get A, B, C. 1, 1/2, and 3. And those are your answers. Alright? If you don't figure them out, ask a neighbor. They can probably show you what happened. Alright? Done.